Here we go, guys. Another example of the mean value theorem, example number 2. And so once again, we have a function, we have an interval from 9 to 65, all right? There's no issues as far as continuity here. There's no division by 0, and cube roots can be applied to any number. So we don't have any issues with continuity on that. So here we go. And again, I usually start with the slope of the secant line side of the ledger here, and you need to find your ordered pairs in order to do that. So when we stick 9 in there for x, that would be the cube root of 9 minus 1 squared. That's 8 squared, which is 64, and the cube root of 64 is 4. Yes. So we've got that ordered pair. Then 65, all right, that'd be the cube root 65 minus 1. Put it in the function, right? Find the ordered pair, squared. Do the arithmetic on that, it comes out to be 16. All right, so 65 plots with 16. Here we go. And there again, I'm working on this side of it. That's the slope of that secant line that connects the two points, the end points of the interval, if you will. So, all right, pause if you ever have to. But that's all just arithmetic thus far. And then the slope of that blue line over there would be 16 minus 4 over 65 minus 9, y2 minus y1 over x2 minus x1, f of b minus f of a over b minus a, potato, 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 all right? And so this is all just algebra going on so far. So this would be 12, and then 65 minus 9 is 56. And I guess we might as well reduce that. I don't think if you divide that, it comes out nice and pretty. I'm stalling here. I think you can cancel a 4 out of both of those. And so that would be, how many times is 4 going to 56? 14 times, 3/14. All right. I think that's good. All right, so that would be the slope of that secant line there. Rise 3, run 14. Okay. Calculus, that's algebra. That's just algebra. Calculus, the derivative. All right, so the other side of the theorem, we will now take the derivative, and it looks to me like we should probably change this into a fractional exponent first. All right, this is just finding the derivative. And so wouldn't the derivative of this be using the chain rule, whereby we do the outside power first, 2/3 quantity, 2/3 minus 1, and then the derivative of what's inside, which would just be 1, wouldn't it? Okay, so this would be the power rule because of that's outside, and then the internal would be a 1. I think we should simplify this a little bit before we move forward. So it looks to me like, well, given the fact that that expression has a negative exponent, it would need to go on the bottom, wouldn't it? And so we've got 2 over 3 times x minus 1 to the positive 1/3 power, and you can change that to a cube root if you wish. I guess we could do that. So 2 over 3 times the cube root of x minus 1 would be our derivative. Sorry for the mess. Again, board space is contracted here, so I'm doing the best I can. And then technically, it should be called f prime of c. So if we basically replace the variable x with c, because this is for every value of x, whereas now we're looking for that specific value, that specific constant, where this theorem basically works. All right, so that's f prime of c. So there's f prime of c, and then here's our slope of our secant line, and the theorem again guarantees that they're equal. So I'm about to erase a lot of things and set these two things equal. Hit pause if you need to write it all down. I know I'm talking fast, but I don't know what else to do. So again, you can always slow things down, pause it, do whatever you want to do. Pause. Okay, now we're going to set them equal. basically, this is going to be just an algebra question at this point. And, you know, like most things, there's a multitude of ways that we could do this. We could clear the fractions first. Maybe that would be a wise thing to do. I don't really care what algebra you follow after this. There's, like I said, a multitude of ways to do it. My thought, I don't know why, but right off the bat, I'm thinking, you know what? We've got the radical on its own side of the equation here, and I'm not 100% sure. Let me see if I've got the link to it. I think I do. Here's my college algebra notes for this, right? Radical equations. Get the radical on one side by itself. This is old radical. This has the radical. It's important to note that's all multiplication and division, so it's all considered one term. So don't we get the radical by itself? We isolate the radical. Sorry you can't see the video.
Be very quiet. I'm hunting radical.
Alright, so you hunt down the radical, and then you kill the radical, right? You eliminate it. Darn it, the videos aren't coming on the screen. Oh well. But anyway, once you kill that cube root with cube, and I might regret this decision to cube it right now, but it's going to work. So 2 cubed is 8, and 3 cubed would be 27. And when we drop the cube on top of the cube root, it would give us just simply the c minus 1. Okay? And then the other side, I know 3 cubed is 27, and then, goodness, what's 14 cubed? I'm already kind of debating whether I decided to solve this in the appropriate way, but it's going to work. So 14 to the 3rd power is 2744. And then, you know, clear fractions, multiply both sides by all the denominators basically. So you multiply both sides by, let's go ahead and distribute this. That'd be 27c minus 27 and 2744. Why am I doing it this way? I don't know. It's going to work. And then 2744 and 27c minus 27. This is just algebra. It's going to get a little messy on us, but that's okay. So this will cancel this. Over here, we're left with 2744 times 8, basically. I understand on this particular question that so-called cross multiplication would have worked, but you probably know I'm not a big believer in that. Over on this side, we're left with 27 times 27c minus 27. 27's all over the place. I did this in kind of a dumb way, but oh well. Let's see, let's divide the 27 out over here. Please be divisible by 27. It's not. 8, 13, blah, blah, blah. Equals 20. I'm doing this in a weird way. I'll be the first to admit it. Then we'll add the 27 over and then divide the 27. And it turns out that the value of c, I have to admit, I probably could have solved that in a much more elegant way, but it's approximately 31.1125. And there you go. So that would be the number there. I'll be honest with you. That was a weird way to solve that, but basically the curve is going to have a slope that's equal to that at that particular place. The curve would be a black thing, and then the tangent line red. You don't have to worry about the colors. But anyway, regardless of my somewhat perhaps bizarre way of solving that, I think that all worked out okay. And there it is. So there's the value of c. Again, I'm kind of wondering if I did that in a good way. It worked. So anyway, I'll get over it. And that's the mean value theorem. All right? So good luck on those.